So welcome to my talk about building smartwatch frontends with Garmin's Connect IQ platform and then combining that with Drupal. There's going to be very little Drupal involved in the presentation, but I guess you already guessed it. So let's start with asking, like, how many of you guys have a smartwatch? Cool. Any Garmin owners here? Right, few, nice. So you actually have the opportunity to take this into practice. Yeah. So about myself, I changed this introduction for this particular presentation. I normally have something else here, but anyways. So I'm not what you could consider a traditional smartwatch or sports watch user. Basically, I use mine for hunting, some shooting sports, occasional jogging, and then weight loss, which is a constant battle. I've been developing for Garmin devices since 2015 when the first Epix model came out. It was a square smartwatch with touchscreen and button interface. And I think that it was really ahead of its time. When you compare it to the current smartwatches that we have, it was pretty not good, to put it nicely. But it already had a support for this Connect IQ platform. So I just, after using it for a while, I just became curious and then starting doing stuff for that and discovered that it's actually really nice. Anyways, if you're interested in the code, you can find it on my GitHub. There's also other samples for Garmin application and some random stuff. So yeah. So this is how my watch applications look like. The first one is a promotional image of the first smart application I made for the Epix One. And basically that was a ballistic calculator. So you use that when you're doing shooting. You shoot for different distances, and you want to calculate how much you need to adjust your scope in order to hit the center for different distances. For all of these watches, basically, for all of my applications, they've actually started from my personal need. I do this for a hobby, so my daily job is working for Druid. It's a Drupal company, but this is just purely as a hobby for me. So all of my applications, they started from a technical challenge. So for example, this ballistic calculation is really complicated math. So I just started wondering whether it's possible to do that kind of complicated and processor-intensive calculations using a tiny smartwatch. And eventually, like after figuring out how to port the GNU ballistics library to the language the watch uses, I managed to do that, and then everything started there. I've also done a hunting application. It's an activity tracker for hunting. The most interesting technical part of it is that I managed to connect well, I have dogs. You'll see it later. But the dog tracking GPS that I use for my dogs, I managed to connect it to the smartwatch application using the ANT protocol. And managed to pull the data from there and then display it on the map and so on. Another application I have is for shotgun sports, like shooting application, and then the last one on the right is it's a pretty recent application, but it's for tracking the electricity prices. So this should give you some ideas what you can do with these kind of application or this kind of applications. None of them are really complicated. They're just one or two technical challenges, but they just display information in a pretty nice way. So yeah, about Garmin. If you don't know, it's originally from Kansas, from the States. But since 2010, it's actually a Swiss company, legally. So it's a nice an addition. Anyway, so the company has its roots in GPS devices, but nowadays they have a variety of devices, like from all the range of the whole spectrum. Of course, we are mostly interested in watches and wearable devices, but then there's like dog tracking tools. Basically, you put a collar on your dog and let it loose in the forest, and then you can use basically a GPS tracker to see where the dog goes and if you don't lose it anywhere. And other hunting equipment such as scopes, I think, for bow hunting tools. Then we have navigators, bicycle computers. Then there's like health and wellness things like smart scales, blood pressure measurement devices. Obviously, also maps, and two different like whole industries like aviation and marine. So there's a wide variety of things that they produce, and some of them actually utilize this Connect IQ, and you can build applications on that. So this is my dog. I wanted to bring him in. Looks like this is from Finland, so it looks like a bit like from Switzerland, at least during the winter, but it's more flat. And the orange thing in its neck is actually the collar, like the dog tracking collar. So anyways, regarding the watch applications, they are pretty much a headache to design for, at least in my unknown perspective, because doing application design, it's difficult enough, but with this small user interface, like, or for these small devices, designing the user interface is really difficult, and there's actually a lot of limitations that you can do with these things from the user interface perspective. So you wouldn't definitely want to edit an Excel sheet with your smartwatch. That's like if you come up with an application idea that you involves, let's say, like typing in a lot of information, of doing something like complicated, like drawing application, even like writing an email would be a really horrible user experience. Or even if you have a simple application, you really need to figure out the flows of the application. In many cases, you have a great idea and you just go into this like full-on engineering mode, and you start doing things in a really more complicated way than they should. The user interface is going to slap you in the face, and you need to simplify it a lot. So the basic idea is the watches are, like the name implies, they are mostly for watching information. You need to like, if the user wants to do something more complicated, then they are probably using some other device to do that. But regarding, they might want to check on, let's say, like statuses, some bits of information or something else, and your application should deliver that information in a really straightforward way. The other key design advice is to focus on the task. So if you are building, let's say like something is like you're building a custom application for a sports event. Let's say you have a marathon in your city and you want to build an application for like sponsored application so that the participants would be able to track the marathon, and you would have like some goals or whatnot on the run. So when the people are doing the running, they want to check the information, like how they are doing, how much there's like time left or distance left to the next stop or whatnot. But they definitely don't want in the middle of their running start like typing in stuff on their smartwatches. So you need to make things simple for the user and really take the user place, like the situation they are into account when doing the design. If someone's enjoying a day outdoors and they just want to track their progress along the routes or the tracks, they definitely don't want to like start battling with some kind of like smart device, because that ruins the experience for them. Then we have the like design. So the smaller the screen is, the better your design should be. The screen real estate is really limited. And obviously, from the design perspective, there are guides on how to design for these things on Garmin's developer site. So they do give you a hint, and you should kind of maybe copy the native applications, how they are implemented, so that you don't create a user interface paradigm of your own and force the users to learn it in order to use your application. That's not a good way to success. Minimize the interaction between the user and the application, and make the most important data easily accessible. Then the other thing is the battery. So what Garmin devices are good for, and there are a bunch of other brands that have similar really long battery life, but if you compare that to, let's say, like Apple or Android platforms, you notice that these both of those, they have really limited battery life. You need to charge them really often. With Garmin devices, this is the Forerunner 165. It's a limited, it's almost like a low-end device in Garmin scale, and it has already 11 days of battery life. But that's because the applications respect the battery life. In Garmin there are you have the native, let's say, experience. You have the user. You have the Garmin platform. Then you have that displays the native watch face, and then you have native applications. Those are really memory and battery effective, efficient. But then when you Connect IQ is something that's been built on top of that, so your applications don't actually reside in the native space, but they are on an abstraction layer, meaning that they have some limitations compared to the native application, and also they can drain the battery much more quicker. So let's say that if you really, after the battery life, you stick to the native watch faces, you don't install a custom watch faces because that drains the battery too much. But this is also something that you need to take into account in application design, because you don't want to be using pulling information from the internet too often, or in a way just keep the track of the resources. And then this is like I mentioned about the design. So these are the devices that support Connect IQ. As you can see, they all look a bit different. We have the bunch of bike computers that most of them have touchscreen, no buttons. 16 devices that you can support. Then we have the outdoor handhelds. That's a prime example. No touchscreen, only buttons. And then we have variety of wearables. You have the traditional one with the round screen, then you have a square one with, I guess, no buttons, and then you have a black and white with really complicated display. And these are all of these are devices that you can support with a single application. You don't need to design a separate application for all of these devices. You can just go through the whole design process and just battle through it. I mean, you have 113 watches to support. It means that the design and the implementation is going to be a bit difficult. So I would suggest that when you start developing, I would probably start with just single device and then expand from that. Some of them have black and white screen, then you have memory in pixel with a limited color palette, and then you have these AMOLED screens that have all the bells and whistles. So, regarding the development, I was thinking that I'll give you an intro. I have a sample application which I'm going to run in the IDE, and I was thinking that I'll just introduce the platform to you, the basic things, then I'll show you the sample application I've created, and then we'll spend the remaining time going over the code base and explaining how it works in practice. So, what are the things that you can build with this Connect IQ? So I already mentioned watch faces. That's the thing. If you want to build a custom watch face, so let's sample, I don't know, commercial cases would probably be that you would use for some company, for example, you would build a sponsored watch face. So for example, I don't know, like a Tesla watch face, you would have the company logo in the middle, and then you would build the watch face around it. Or for practical reasons, maybe if you're really depressed, you can build a custom watch face for yourself. that in addition to showing the current time, it would show you the percentage of that particular day that you're spending in meaningless meetings or something else. But that's just like, the watch face is always visible on this device. So basically, that's what you look when you just glance at the watch. And that's a huge thing in the Garmin ecosystem. Most of the applications you can find in the Garmin store are watch faces. People want to customize it, and you, even though there's no like way that you can charge people for your software in the Garmin app stores, everything's currently free. You can do do a licensing thing that enables more features. For example, the watch faces. I know people who make like several thousand euros monthly for just selling watch face licenses to the users who want to customize them. It's not a 100,000 euro business, but I mean, if you have the time and you want to do watch faces, you can also earn some pocket money doing that. Then we have widget and glances. So when you have a bunch of widgets, when you go out of the, when you press a button on Garmin screen, it takes you from the watch face to a widget list. That's where you can browse through quickly all the applications you have on the installed that have a widget enabled, and they show you different types of information. So for example, they show that what was your last activity, how well did you sleep, and so on. So this is really like quickly glanceable information. So you can build, for example, in my application that I showed briefly, the one that shows you the daily energy prices, for example, in the region that you're located. There's a glance that shows you the current hourly price. So you can either just go to the glances and see how much electricity costs at the moment, should I put on the washing machine or not, or then you can open the application directly from the glance, and then it opens the full device application, which is the next type of application. So device applications are the, I don't know, like most powerful application in this Connect IQ ecosystem, in that sense that basically it's an application. You start it, the application does whatever it wants. It has access to all of the APIs. So for example, from the battery use drainage perspective, you obviously can't do a watch face that's current, that always running and then use a lot of resources, because that would drain the battery really quickly. So there are API limitations. That not all the APIs are available for watch faces or widgets. But device applications, they get access to the whole stack of APIs. You get the communication, you get sensor data, you get whatever. Then we have data fields. These are fields that you can add, for example, native application. So if you have a smartwatch, you know that you can, there are a bunch of like native applications, so for example running or snowboarding or whatever. And those are, in this ecosystem, they are mostly created by Garmin. But if you want to add a custom field, like that you build to a single like this one of these activity tracking applications, you can. So for example, I would be able to generate create a custom field that calculates the calories that I've been spending in the sport so far, and convert that into bottles of beer. So I would be using the custom field in a regular running activity, just to see that how many bottles of beer I can drink after the exercise without gaining weight. So this is the type of data that you can use in the data fields. Then there's a separate category of applications that are audio content provider applications. So basically those are watch applications that can stream audio. You have a Spotify application, you have a heart radio application, I think, and so on. So if you want to build your own audio content provider application, this is what you would do. So to get started with the Connect IQ application development, it's pretty straightforward, at least on the paper, but you just download the SDK. You go to developer.garmin.com, you download the software development kit, you can start reading the API documents to get an idea what you can do. You need to generate a personal developer key, and you keep it as a secret so that you can update your applications later. You write the application, you can run it in the simulator, you can test it using the tools provided. There's a testing framework and a lot of other testing tools that you can use. And then you can submit the application to the App Store, and then it appears to the App Store. Basically, it's the App Store can be found in the apps.garmin.com address. But you can see that these are the most popular applications are the Spotify and the Deezer, so both of those are audio content provider application, and then you have different types of I think those are watch faces, so you have 2 different types of watch faces, but that's just a sample. So regarding the language that the applications are developed with, it's called Monkey C. So the Connect IQ is the platform, the SDK, the APIs and so on. But the language you're using, it's a custom application, language, programming language developed by Garmin, and it looks pretty much like that. So you can see that it's pretty straightforward. I think that they advertise it to be a cross-breed of between JavaScript, PHP, and so on. So it looks pretty much like any other language that we are familiar with. This sample here doesn't include typing. So they started with an untyped language, and then they added the typing afterwards. It generates a bunch of issues, I think, in my opinion. The typing is still optional, so you can set in the compiler that the level of type enforcement you want to use. What's funny is that the samples in the Garmin website are mostly untyped, meaning that you need to figure that out yourself. Also regarding the APIs, for example, it's not that they haven't changed the APIs too often, so you have a library called Menu that was published in 2015 with the first version of the Connect IQ. Nowadays you also have menu 2. So it means that they have been adding stuff on top of the old stuff and so on. So you have menu 2, then there was some other classes that were titled with 2 on them. So they definitely haven't broken the backwards compatibility at any point and so on, but yeah. But Monkey C is pretty straightforward. I won't be going into details of Monkey C because you probably, if you do any software development, you probably can get the grasps from this. This language is somewhat detailed on the developer website, but I have to be honest, sometimes if you want to do a particular thing, like using enums or something else, something that you don't do that often, for example, you might need to dig a bit until you find what you are looking for, or then just try to wing it and hope for the best. It's all the practices feel a bit familiar to you, but it's the documentation, it's not that good regarding all the topics. Well, anyway, so in addition to the language, you have the APIs, the SDK. So I'm going to go over the other components that are involved in building an application. So first of all, you have the manifest. That's what defines your application. You define it's an XML file, but you have in the Microsoft Visual Studio, you have a nice interface for editing that, but in that you define what type of application you're building, what shop, you define what's the minimum supported API level, and then you can define the name of the application that it's displayed in the menus, the entry point to the application, what's the point that this execution starts, some icons and unique IDs for the application, and then there's a list of permissions that your application needs to ask from the user, and a list of products that you want to support, and so on. Then we have the application itself. So this is applications have a life cycle in that sense that it doesn't you don't really control your application. The user starts the application, but then, for example, if someone calls the user's phone while they're using your application, it will get suspended because the watch will display the caller information and some other stuff. So you never know in what state your application will be. So this is like explained with the application lifecycle. You have or if your device runs out of memory, it can suspend the application and so on. So you need to just take care that whenever the application gets suspended, something happens, the user gets a notification, the application goes away from the foreground. You need to manually save the state of the application so that when the user resumes using the application, it goes to the place where it was left off. But typically the most important thing that happens in the application file is that it returns the view that gets rendered in the application, like using this get initial view. Then we have the views. So basically views represent the pages of the application. They have a layout, they contain the user interface components, and then they also have a life cycle of their own. So the life cycle is that like at some point the view is being rendered for the first time, it's being made visible. Then at some point maybe the user clicks on some element and another view is placed on top of that view in the stack. The views are like basically it's a view stack. Or when something happens again, there might be like I don't know. Again, the application might get suspended, and the view, when it gets brought back to the foreground, the view is being rendered again, and so on and so on. But these are basically, I would call them like the pages of the application, because these are the things that you actually design. The view, basically, you render the data, you pull the data from wherever, and then you render it on these views. There's like a layout system. So basically these are XML files that you can configure that contain the graphically, like the user interface elements in an XML, or then you can draw them manually in code. The layouting system is a bit limited because there's 119 devices to support. So in theory, you might need to create a different, separate layout for each of the devices, unless you get really lucky, or you decide to support only round devices with 5 buttons, for example, and so on. Typically, what I personally do is that either I use the layout for simple things, but when I need to do something really complicated, I want to do that in code, because in code I can actually adjust based on the device dimensions. I can just scale a bitmap to fill the whole screen, or do stuff like that can be done in the layouts. Also, it's really important that since you don't really know when the view is going to be rendered, you shouldn't alter any data in the view. I'll just show it later. But this is basically how a pretty much empty view file looks like. So you have it's a class that extends watchUI.view. I've named this main view. You initialize the class. This is just like normal object-oriented stuff. Then the lifecycle function on layout means that if I would be using layout, the XML file, I would here, I could load it here, like using the set layout. I'm loading the layout from the resources and just rendering it. Then we have the onShow function that gets run when the view gets displayed for the first time, and then we have the onUpdate. So the onUpdate function is the most important of all of these, because it's where you get the data, you actually display the text there. You pull the text from your string resources, and then you just place the text inside the layout elements or whatever. Or if you're doing animations, the onUpdate is actually where you would render a single animation frame, for example. And then we have onHide, which is when the view gets hidden for some reason, so you can release any resources you might have done or hogged for your application. Most of the time you're just going to play around with on update because that's where the magic happens really. Then we have the input handling. These are things that, like I said, you have round watches, you have square watches, you have watches with buttons, you have watches with touchscreen and so on. So you need to have a lot of abstraction in order to serve for all of these like devices. And basically this is handled by the delegates. So delegates are practically, they are listening for user input and then reacting to that, maybe switching views from another. So when you press the next button on your device, they just render another view, take the user to some other page in your application and so on. Or then if you're using like, let's say, since you're not supposed to alter any data, so for example in the views, because for example on update view function might be rendered like multiple times if you're doing animation or something else. So definitely you wouldn't be altering data there, but in the delegates, for example, when user press start button, you would be able to start tracking some activity and so on. So this is where you would do like you would alter your model or something. Then there's a bunch of pre-made views like that are made by Garmin, included in the SDK for really complicated stuff. For example, there are progress bars, there are text pickers, that's a user interface that you can use to ask the user to type in some text and so on, confirmation dialogues or native looking menus. So you don't need to build all the user interface elements from scratch. There are a lot of like pre-made that look pretty nice. The delegate is like looks like this. So again, you have on next page, which just like this is a behavioral delegate. So for example, on next page means that the user is doing some kind of like gesture, for example, that they want to go to next page in the application. So in an application with buttons, for example, they might press down button and that takes them to the next page. If they don't have any buttons in the device, if they swipe from down to up, it would trigger this function. So this is how you work with different kind of user interface in the Garmin ecosystem. Then we have, so for example, here you can see on next page, we're just switching from one view to another. Like in the sample application, we are just like showing another view, and then we're using an animation slide down to do that. And on select, it's just doing something else, and just pushing again doing something, and then pushing a new view to the view stack. Then we have resources. These are things that you can actually customize per device. So you can have different, these include the layouts, they can include images, texts, font, and even like static JSON data. So these you can customize per element. This is actually where you can do most of the customization. So you can have different layouts, you can have different pictures or images for different screen sizes or different forms of display and so on. So that allows you to actually support this amount of like devices. These are defined mostly in XML files, and then there's like some magic that happens in the background. The resource compiler processes these XML files and then generates code about them. But you can see basically this is how it works the inheritance. So for example, you have the resources folder that's the basic like resource folder. Then you can have a separate resources for round watch faces, or you can have a separate resource file or folder for a specific device like Phoenix 5 in my case. Or you can even have separate resource folder for Phoenix 5 devices that are using German language. So for example, so this is how you can just like have custom resources for different types of screen, different pixel sizes, or even like different languages. This is how a resource file looks. This is a bunch of like bitmaps, launcher icon that just this is the resource ID and where it maps into, like in which file it maps to. And we have another resource ID splash comic which maps into this image. And then in your code, you can just use the resources like this. You can use the application.load resource, and then you give the resource ID, and then just use the drawing contexts to draw the bitmap. So layouts are, like I mentioned, it's a way of almost like creating an HTML, but in a shitty way. So this is like how you would build the layouts, and then you can just extend them inherit them in the resource ecosystem. Like I said, they are not very dynamic in nature. So for example, you can just put an image to your layout, but for example, you can't put an image that scales to fill the whole screen. They just assume that you have different layouts and different resources, like different images for different kind of screens, and so on. So these are something that when you start working with these, you might get a bit frustrated and then be like me and start doing everything in code. So just to avoid the abstraction layer that doesn't seem to be working at all times. But this is how it looks like. Basically, we have a layout, a specific layout called main screen layout. You have one bitmap that is from this file, mindscreen/mv. You position it to the center of the screen in X direction, and then 5% from the top. Then you have another you have a label that we use these for displaying text. You have a string resource here. These are used for translations, basically. You can define color, and then you can define font if you want, and then you can define justification, whether it's left justified or center justified, and so on. And if you want to, when you want to use it in this layout in your view, you just like on layout, you just set the layout, and then it gets rendered pretty much automatically. We also can persist data. There's a storage module and so on where you can put them, and then you have a type of like persisted data and so on, and so on. So there's a like you can store data to the device and so on. Then we have communications modules and so on. Anyways, so I'll just show you the application I built. It's a sample application, should give you some idea what the application looks like. It's a simple game called Bomb in a Microwave, where when you start the game, there's a counter that starts counting down from 4, 3, 2, 1, and you should stop the clock exactly at 0, and then you get points based on how close to the absolute 0 you managed to stop the clock. It's quite straightforward. And then if you go past the 0, the bomb explodes and it's instant game over. Basically, we have here like the components are, we have the basic application, we have the views and delegates, we have a model that actually contains the game logic that directs the views and the delegates, and then we have a bunch of resources. The basic architecture is that you have the application, that returns the initial view. We have a splash view, so it shows a nice splash screen. Then it takes to the main menu, and along with the score view. We have the round, like when you start a new game, it shows you the game view. After each round, it shows you the results. And if you get a high score, then it shows you the text picker so that you can type in your initials. And then we use the model to keep track of where the game is going, and then save and download the high scores. So let me just show you how it looks like. So this is the bomb in the microwave, and I'll hope that I can manage this to work. So I'll run it with this Epix device. So this is like, I'm just starting the application in the simulator. And now showing the splash screen, showing the name of the application, and then we have the main view. I can toggle here to see the high score list, like pressing up and down. And then when I start the new game, it says that 4, 3, 2, 1, and I need to press this start button at exact 0. It gives me the round results and then the total score, 4, 3, 2, 1, 0. Oh, yes, good for me. This is actually really hard, so just like maybe I'm really focused now. Anyways, and this is the last round, and now it says that I got a high score, and now when I press forward, I can just show you how I'll just add something custom here, like this, MMM, and I'll press OK, yoink, and now you can see that I actually made it to the top of the list. So this is like how the basic functionality goes. The high scores are stored in Drupal. I use JSON API and then some other modules that to store the for the API. And then I actually have it here. So you can see it's like I have JSON API and then RESTful web services. The reason I'm using these two is that I started with JSON API and I was managed to pull the high score information from there. But in order to upload a high score, I needed to provide a certain content type there that I wasn't allowed to do from Garmin. So I'm just like the RESTful web services actually seem to be accepting just like application JSON content type, which the watch is happy to provide in this interface. But I'm now going to run you through the application really quickly. So you can see that this is the entry point for application. I just create a new game model. Like I said, this contains the application logic. This returns the initial view, which is in my case it's the splash screen. And this is how the typing looks like. As you can see, it's not that clear always, but yeah, I'm just returning one splash view, and then there's a global function that I can use to get the application instance whenever I want to have it. And now I'll just show you how the splash screen view looks. So basically, this is a view, and I'm not using a layout here because it's I didn't want to. I felt it didn't work here. So when the view is displayed for the first time, I initiate a new timer that calls this callback after 2 seconds, and then I render the page. So this is the view on update. So you can see that I start drawing on the screen. So I'm drawing a scaled bitmap in the far top right corner, and I scale it to the actual screen size, and I'm using this resource. And then we have the go forward that gets called after 2 seconds. As you noticed, at first there was this image on the background, and then after 2 seconds, the name of the application just appeared. So this is what I'm doing. Like during the first run, you actually get to you can see the only the screen. Then when the callback is getting called after 2 seconds, I'm just like going to display the text, and I'll request that the screen gets updated. And then when this callback gets called again, I'm just going to go to the next view, which is the main view. This is the main delegate view. No, actually, this is the main view. So on this view, I'm actually using the layout. This screen only displays the tiny microwave on the top and then the start game text. So I have it defined in the layout, and then view on update, it just renders the layout. And in the main delegate, you can see that when the user presses the next page, basically wants to go down, I'm just switching to another view, which is the high score view list, and then just rendering that. And if they, on the other hand, if they press the start button, I am getting the model, starting a new game, and then going to the game view. So this is like the basic functionality. This is the bread and butter of Garmin development. You create views, you configure delegates, and then you have some kind of model that interacts with some kind of backend. Interacting with the backend is, like I said, it's going to be, since this is somewhat about Drupal, so I'm just going to show you how it works. So, for example, downloading high scores using Garmin is just basically I have the URL. It's a local host here, and I'm just putting in some parameters, putting in some options, and then I'm making a web request with URL parameters, the options, and then I have a callback when we finish the execution of the when the web request is finished, and then I just process the data here and so on. So this is pretty like, I mean, it might look like exactly like what you'd be doing in some other language like JavaScript and so on. But yeah, this is pretty much how it goes. In some other application, for example, your model might start tracking an activity. If you made a custom running application, you would just display the splash screen. If you're into splash screens, I like doing splash screens for my application because the application typically looks so boring, so at least you have one point where you can put some pictures. But then when the user would actually start using the application, they would press start. The application would start tracking call the model to say that, hey, let's start tracking an activity, and so on, and you would just be like updating views, creating delegates, and so on. This is like basic stuff. I think that the most important thing is to realize that the documentation basically tells you what kind of functions or APIs you can use, what kind of stuff there are available, but they don't document what's any recommended application architecture. So the first time you're doing something complicated, you end up like needing to figure that one out. So in that case, I would recommend just going to GitHub and seeing how other developers have been doing this and so on. But this is it. It's a short introduction to Garmin development. And do you have any questions?
We have time for one question.
Okay, cool. Yes, thank you.